Did you know your ability to play has a lot to do with what you eat and how you move? What you eat provides you with energy to move, and knowing how you move and how to move safely will make you more efficient when playing. Let's take a few minutes and dive into how do you play? Have you ever heard, you are what you eat? What if it were true? Well, we don't see a lot of people walking around as donuts, but what you eat does affect how you play. There are many essential nutrients that are needed for your body to play. Potassium, sodium, calcium, and water are all very important. Why does this matter? And where can you find these essential nutrients? Food is the fuel your body needs to perform at its best. And it all starts with your brain.
The brain starts the signal, and with the help of potassium, it passes it along your nerves.
Fruits and vegetables are a great source of potassium. Drinking a glass of orange juice would provide you with the potassium your body needs to send signals from your brain to your nerves.
Sodium is used to give the message from your nerves to your muscles.
Sodium is salt. It can be found in almost all processed foods, though a healthier way to get sodium in your diet would be to add a small amount of table salt to your vegetables.
After the message gets to your muscles, it goes deep down into what are called muscle fibers. Muscle fibers contain muscle cells, and inside muscle cells are structures called myosin and actin. Myosin and actin overlap a little when your muscles are relaxed, but once it receives the message, they use calcium to pull on each other and contract the muscle.
Calcium can be found in leafy greens or in healthy cereals like Cheerios.
If you are not getting enough calcium in your diet, your body will steal calcium from your bones. This is what causes weak bones. If you do not have enough potassium and calcium in your body as well, your nerve cells will become extra sensitive, causing cramping and pain. Without enough sodium in your body, it has to try extra hard to send a signal. This overworking of your body causes cramping. As you can see, these two marathon runners are having a tough time reaching the finish line due to their very low levels of potassium, calcium, and sodium, causing them to cramp up.
Water can be found in H2O. H2O is just a funny way of saying water, so really the best way to get water is to drink a big glass of water from the sink. Did you know that your body is made up of more than 60% of water? It is important to drink at least 4 glasses of water a day so that our bodies function at their very best.
Now we know which nutrients are important and where to find them. But what about how you move?
So the process by which we study movement involves some sophisticated tools like digital infrared cameras and reflective markers. What we do is we place these markers in certain spots on the body, and that allows us to reconstruct the way that a person moves. So if I put these markers on my arm, I can reconstruct this segment of my arm, and then I can look to see what the motion of that arm is, maybe during a throwing motion or a volleyball spike or even a golf swing. So on the screen here you see an example of a quarterback throwing a football. This is actually Tom Brady. We were filming him in the laboratory so that we could look at his footwork and his joint angles during his 3-step drop and his throwing motion. So one of the things that we're able to do is we're able to take those reflective markers that we put on the body and reconstruct Tom Brady's skeleton based upon the locations of those markers. Now in the laboratory we have a coordinate system, and each one of those markers has its own coordinates relative to the position in the lab. And so when we have those coordinate systems, we can start to calculate things like the angle of his knee and the angle of his throwing shoulder and the velocity that his hand is moving during this throwing motion. One of the things that we can examine from a mechanic's perspective is how efficient a runner is during their running. So we can look at their joint mechanics and start to relate that to oxygen consumption while they're running and look to see how we can make them more efficient, either by the way that they're moving their arms or how they're holding their trunk, or even the length of the strides that they're taking. Our motion analysis allows us to rotate this around and look at the person's movement in a three-dimensional space, and allows us to very closely or very accurately examine many aspects of the way that this person is running.
Take a second to think about what you've learned today. We've looked at nutrition, sodium, potassium, calcium, and water, and what roles they play in your body, anatomy, how your body moves, and physics, the body analysis on the computer. By applying math and science, you're able to look at how efficiently you can play. So next time you're out, think about it. How do you play?